Good morning students. Welcome back to your mathematics class. We are again moving with the same topic of integration. Last class it was a introductory class for another 6 to 7 more standard integrals. I hope all of you have tried deriving them by substitution method. So we will be continuing with the same topic and we will be doing today the problems which are based on those new standard integrals introduced to you in the last class. And let us complete the entire session with solving certain problems based on this. So let's begin the class. Okay, so I have taken a first problem for you. As of you can see here 1 by x and the bracket starts 6 into log x whole square plus 7 log x plus 2. Now definitely you all understood here that these logs should be substituted with a new variable, say t or y. Why such thing? Because I have a derivative of log x, that is 1 by x dx is equals to dt. Yes or no? Okay. It is then going to be reduced into a rational function whose polynomial is going to become a quadratic equation. Now, so how it will look like after the substitution of t? Let's see it. So this is going to become, this entire thing with dx is going to become dt. So I'm writing it. It is dt by 6t squared plus 7t plus 2. Now, all of you see very carefully, here in the denominator, it is not in a type from where we can have a direct formula for standard integral. So what we have to do? We have to make it in such a way whose integration is known to us. Do you remember in class 10 we have done the completing the square method? I hope you all remember this one. So I'm going to apply the same over here. I'm going to use the completing the square method here in this particular problem. So for that, what I'm going to do? See, this is a 6 over here. Can I take a 6 common? So it will become 7 by 6 and a 2 by 6. I think there is no problem in that. Now, I want a completing the square method. That means I want to make it a whole square formula. For that, look very carefully. This 6 first of all is out. And there is a term 7 by 6t. This is a middle term and doesn't contain any 2 here. So let us multiply the particular term by 2 in the numerator and the same in the denominator. So how does it become? T square plus 2ab, consider like that. But again there is a problem that we do not have the third term even, that is b square term. I have a square term, I have a 2ab term, I don't have a b square term. How to manage that one? So for that something should be introduced as a, see, it can cancel 2, 3 also. Look and focus in this particular point. What am I doing? See, consider 2ab. It is there in your mind. So a square is there. 2ab. B part is how much? 7 by 12, isn't it? I'm going to add a 7 by 12 whole square. 2. Manage it. I'm going to subtract another 7 by 12 whole square. So look at the terms I'm taking. A square plus b square plus 2ab, and the left outs are these 2. This point is very important. I want you to understand very nicely at this particular thing. What I did, I tried making here a plus b whole square formula. but I was not having a 2 here. I managed a 2 in the numerator and the same in the denominator. On managing the same, I am getting a b square. That b square is added and the same is subtracted, so that there is no change in the denominator expression. Okay, so now I have a plus b whole square thing. What it is? A plus b. B is 7 by 12. Okay, so I am writing here 1 by 6 integration of dt t plus 7 by 12 whole square. Now this is what? 1 by 3 minus 49 by 144. So this is how much? The subtracted term is 49 by 144. So 1 by 3 minus 49 by 144. Fine. Now let me erase this one particular part. Now I am very much interested in the new thing which I received just now. Here it is giving you 147 and this is 1 cancelling down to 1 by 6 dt by. See, the new expression comes down to what? See, this is t plus 7 by 12 whole square. And what am I getting here? See, a minus sign will be coming. Okay, so let me write it like 1 by 12 whole square, because a 3 was also coming, which is cancelling down the 1 in the denominator. Okay, the LCM is 144 into 3. Correct. Now this is what formula? What type of formula is it giving you? This is the one I wanted to use here. Okay, so this is what? Dx by x square minus a square. So what is the formula for that? Tell me. Yes, it is 1 by 2a. Do you remember all? This is log x minus a by x plus a plus c. It is advisable to you, all of you, please write down the formula first. It is very much important to all of you. Now I am going to apply the same here. This particular formula I am going to apply here. Okay, so here what it is, x is t plus 7 by 12 and a is 1 by 12. So what I am getting? The new and the last expression, it is 1 by 2a. A was 1 by 12 log. It is t. What was that? It was t plus 7 by 12 minus a. Then t plus 7 by 12. T plus 7 by 12 is considered as x. Plus c. Never forget to put that. So, the last but not the least part, that is the substitution. The substitution was t considered as log x. Now what I have to do? I will be putting here log x in the place of t. The last and the final thing, I am going to put here log x. Okay. Now, so after putting the log x, let us calculate this one. So it will become 6 by 12, that is 1 by 2, and this will be, okay, this will be 7 by 12 only. Okay, so this will be, yes, because you have this 7 by 12 only. So, and this is 8 by 12. So I am going to write this, cancel this 2 with 12 also. 1 by 6 log of, this is log plus 1 by 2, and this is log x. This is 8 by 12. So cancelling down, it is you are getting 2 by 3, and don't forget to put that c. So here is your final answer. Okay, so after this one, let us move to the another problem. I hope you understood that how to make the denominator into completing the square method. You have several problems. I have already sent you PDF material on Friday. I hope you have seen that one. So we have so many problems based on this particular type of category. Please do follow them also. Now I want to discuss this particular problem. See, x to the power of 4 plus 1, here it is dx. Now in this particular category, it is very important because we are not able to factorize this particular thing the way I did in the last problem. So this particular problem can be solved by a very unique technique, and I hope you will understand the one, and it is really most important, one of the important problem also. Please carry on with this such type of problems you will find in your book, and let's see how to solve it. First of all, we have to do certain changes in the numerator. We do not have a numerator other than 1. So I'm writing one thing, and you just tell me whether I can do the same without any problem or not. Please do focus the numerator. Okay, I'm not rushing with this. 1 is converted into x square plus 1 minus x square minus 1. So imagine the entire thing opening. What remained? X square cancel into x square, and I don't have x square term here also. That's why a minus I have put. Now this 1 doubles to 2. How to manage that? This is the 1 by 2. I hope you understood this particular technique. Separating the numerator. What are you getting? On separating the numerator, I am going to write down here dx and x square minus 1 dx by x to the power of 4 plus 1, and see, I have put a third bracket. The entire thing is multiplied with a half, not to forget that. After this, do you think we can cancel out some factors from here? No, isn't it? How to do it? Now students, I want to bring your attention to a very important technique, method you would say, which can be used not only in this problem but also in another substitution methods also. See what I am going to do here. I am going to take out x square common from the numerator and x square common from the denominator. How the entire thing is going to turn up then? Imagine an x square is extracted from the numerator, same is from the denominator. It will become, the denominators are going to become like this. Like this. Here x square is common. Then what are you going to write down here? Here it was x square plus 1. So 1 by 1 plus x square. And the numerator is common from the numerator. X square is common from the numerator. Then see, this x square will cancel with this x square. This x square will cancel with this x square. Now after cancellation, how it will look like? I am writing this particular part again. So this particular part was dx by okay, and After cancellation of this x square also, this particular part is like this and the half is outside. Now very important thing is going to come now. A very important substitution. See very carefully. The denominator is x square plus 1 by x square. Do you all remember the a square plus b square formula? Yes, of course, being in class 12, you will say, definitely we're going to remember that formula. But I'm going to write it in different way. What I want to tell you, students, here, a square plus b square can be written in two ways. No. We can write a square plus b square as a plus b whole square minus 2ab. In the same manner, I can write a minus b whole square plus 2ab. Correct? So I'm going to utilize this particular technique in this particular integrands. Now, how it is going to help me? See here. This x square plus 1 by x square, I'm going to mold it into a minus b whole square plus 2 ab. ab is not going to remain back because x is going to cancel with 1 by x. And in this particular part, I'm going to write down x plus 1 by x whole square minus 2ab. Have a very clear focus on this. And what is the reason for my choice? Who is bothering? Which substitution technique is going into my mind? It is plus, then it is minus, it is minus, it is plus. Why? See, focus. To this substitution I am using. Two problems are moving parallelly. Two integrations are moving parallelly. Here it is t. So what is dt, dear? It is 1 plus 1 by x square. Yes or no? Yes. Okay. See? This is the only reason. If this is t, then this is dt. And if this is u, then this is du. Are you getting my point? If this is t, then this is dt. If this is u, then this is du. So proper substitution is important. So the entire integrand is now in terms of t. What it is? In the numerator it is going to become dt. In the denominator it is going to become t square plus 2. Correct? Here this is going to become du. Here it is going to become u square minus 2. I am going to write that. Erasing. Now this is du. And this is u square minus 2. Yes or no? So that was my choice of substitution depending on what I have in the numerator. So 2 can be written as root 2 whole square. Okay, we are ready to apply the formula. Dx by x square plus a square, what it is? I wish you are all in front of me and I am asking you one by one, making you stand. Hey, you stand up and tell me the formula. Hey, you stand up and tell me the formula. Okay, and definitely you're going to answer me. So here, I have to substitute the formula. Nobody is going to answer me except myself. So here it is 1 by 2 outside. So what it is? 1 by root 2. Someone is thinking, oh gosh, I'm saved. Ma'am is not here in front of me to ask me the problems, the formulas. Okay. So the time is going to come soon. Okay. See, 1 by x square plus a square dx. So it is 1 by a tan inverse x by a. That was the formula. So here it is x acting as x, and here it is root 2 as a. So 1 by root 2 tan inverse of x by a. Okay. Now this is again the same one just now we have used in the last problem only. 1 by 2a, that is log x minus, okay, this is u, x minus, and c, of course. Without this we cannot finish our answer. And the last but not the least part, you all know what to do. What to do? This is t. You know what is t? You substituted t, substitute here. And convert this one also in the terms of x. That I am leaving on you. Because up to this only is a very important thing to complete. Now, this is a very important problem because of its technique. Because the two integrands are running parallelly. Because we are having lot more to go through. Like a very important problem, root over of tan x is following the same type of technique. I will just begin the problem and the rest you are going to finish. See, this problem is there, this integration root over of tan x dx. Okay. Now definitely a root over is not digestible. We need to get out of it. Okay. So let us substitute tan x as t square. Okay, fine. So I am out of it. But not leaving behind the dx part, differentiating both the sides, that is 2t dt. Correct. Now tan x derivative is secant square x dx. Correct. What is dx? I don't need sec square x. I need only dx part. So 2t dt. Now here it is 1 plus tan square x. I am converting secant square x as 1 plus tan square x. What is tan square x? It is t to the power of 4. You know, students, I found so many copies when the students are with the problems, rushing through all the 30 problems they are getting in the examination paper. They land up writing only t square here. Very, very common mistake I found in the copies. Please be very careful while converting into new variables. Okay. So it will be t to the power of 4, not t square. Correct. So now let's substitute everything into the main integrand. It is t only, and value of dx, that is 2t dt by t to the power of 4 plus 1. So what are you getting? See, you are getting 2t square dt. Fine. Now, 2t square. 2t square can be written as t square plus t square. Yes or no? 2t square can be written as t square plus t square. And you are going to receive a same type of problem, the one we did just before it. See how I am writing and how it happened. 2t square is t square plus t square. Adding 1, subtracting 1, separating the numerator. Here it is. Don't you think so? This is the same one. Only the previous one was in x. This is in t. So, will you be able to complete it? Yes, I'm sure you will be able to complete it. Okay. So, this one you're going to complete. One more I'm going to give you. This also you will be completing as your homework. You will complete root over of cot x. You will complete root over of cot x. These all are your like homeworks. Okay, you complete it because these problems are based on this type of techniques only. Okay, so I hope you understood that why the integrals, the standard integrals just in the last class we introduced are very important. So several problems are there actually. There are a lot of problems. following this particular formulas. So please children, go through that. I will be providing you in the PVF materials many more problems like that, and you have enough, I think, a lot of collections of books also to practice more based on this one. So that's all for today. Okay, and keep practicing. Have a good day.